Life cycle of a star or stellar evolution, how the stars are born and how they die. So that's what we're going to talk about here. So sun is a star. So that is so this is sun. So sun has been like how we see sun for the at least for the last 5 billion years. 5 billion years. And it will be functioning as it is functioning now for another 5 billion years. So the phase that the sun is in, we call it a main sequence. Main sequence. So what is main sequence? At the center of the star, if we draw the center here, at the center of the star, what's happening is that the hydrogen is fused into helium. Hydrogen is fused into helium. And as long as the hydrogen is fused into helium, till the hydrogen runs out, the sun will stay in that main sequence, that's the main sequence. So this is a kind of a term that's used a lot about this life cycle of stars. So when a star is in main sequence, that means that it's a fully functioning star and that has got a core where hydrogen is fused into helium. So the time when hydrogen runs out, the star will leave the main sequence and it will be a red giant or super red giant. So it could either become a red giant or supergiant. It depends on the size of the star that will determine what the star will become. So now we are going to look at a star like Sun and how a star is born and how it will die, because we looked at that the sun has been there 5 billion years and it's going to be staying there for 5 billion years in the main sequence. So let's look at a full life cycle of a star like sun, how it's formed and how it will develop into a red giant and what will happen after that phase. So a sun like star is formed like when you have um, dust and gas particles. So these are dust and gas particles in the universe. Where did they come from? They came from when the previous stars were blown away through supernova, the process supernova. So these um, were kind of gas particles, or uh, probably they have got all type of different chemical components, and simply dust and gas. So what's going to happen to this gas and dust is that they will contract, or there's something we use gravitational collapse. So they will contract under gravity. So which means that they are going to, so let me, so that is gravitational force. So they're contracting under gravity. And what's going to happen is that now you're going to have a something we call a prostar. So this is a this is a prostar. So prostar, and we still have the contraction, gravitational contraction towards. So this is a prostar. So all these gas particles are now in here, gas and dust, everything. So they came from the previous star explosions, or it could be the first generation star. That means that after the Big Bang, we had hydrogen and helium in the universe, that they all contracted under gravity. So it's called gravitational collapse. So we call this a protostar, not prostar, protostar. So, so this protostar, so what's happening is that we have a core in the middle. So in the middle, we have a core. So that is densed. That core is densed, but it will be very hot because when gravity is compressing and contracting and collapsing under gravity, and that will exert so much force on the core, and the core will become very hot. And when it becomes hot, what's going to happen is that the hydrogen in the core is going to fuse into helium. Due to the fusion of hydrogen, we are now going to have outward pressure. That outward pressure from the gas and the radiation pressure is going to balance the inward pressure that's coming from this gravitation collapse. So that's going to balance everything, and this star will become a main sequence star like Sun. So when the forces from outside or the gravitational force, so all that's happening is the gravitational potential energy is converted into heat and kinetic energy, and due to that heat we have got hydrogen fused into helium here, and that radiation pressure is now balanced by this gravitational force. So now the star is going to stay in main sequence just like the sun for a very long time, depending on the size of the star. For instance, if the star is very small, it might even last for trillions of years, but if it's like a sun, billions of years. But if it is a huge star, then there's so much gravitational pressure towards a core. That means that hydrogen will turn into helium, and helium will turn into carbon and oxygen, and it will continue to fuse into lots of elements because there's so much heat available. But the fusion process is faster. That means that they will all quickly run out. The fuel will quickly run out, and this star will leave the main sequence very soon when the star is really big. So sometime it might leave the main sequence only a couple of millions of years. Let's come back to the sun-like star. So the hydrogen has run out, and what will happen is that when hydrogen runs out and there's not much pressure outward, so it's going to contract the gravitational collapse. So it's going to contract more, and it's going to heat up the core. It's going to heat up the core, and because of the heat, the outer shells will expand and will become big and cool down, and this one is going to become a red giant. So now, for instance, Sun is now a red giant after um, 5 billion years. So any star like Sun will become a red giant when hydrogen runs out in the core. That means we have all these outer shells, but it's really big. That means the star is now very bright because it has got lots of surface area. So now we have core where the hydrogen has everything turned into helium. And what will happen is in the outer layer, like here, in the outer layers, we still have hydrogen everywhere. So what will happen is in the outer shell, the hydrogen in the outer shell will start to turn into helium. So hydrogen into helium. And here, the helium will turn into carbon and oxygen. So they are going to fuse into carbon and oxygen, and this one outer shells, the hydrogen turn into helium. So for a star like Sun, that there's nothing will happen after it turns into hydrogen and oxygen because the heat the that we get from this gravitational force is not enough to fuse into other elements. So carbon and oxygen would be the last elements. And outer shell, we have got hydrogen turn into helium and it's going to form a helium shell. But still, the gravitational force is coming towards the core. But the core for a star like Sun, when it's in the red giant phase, we have got something called this pressure from the electron. So that pressure will not allow the gravitational force to contract the core anymore. So it's going to fight back. So what's going to happen is that this helium shell is going to pulsate. It's going to pulsate. So it's going to pulsate and it's going to expel all the shells outside. So what we get is that this core will become a white dwarf. So let's write that's a white dwarf. And the the outer shells become what we call a planetary nebula. So that's basically full of dust and gas particles. So all this blown away like a planetary nebula, and that will give birth to another star in the future. If the original star is more than 8 times of the mass of the Sun, it will become a red giant or a super red giant, but it won't straight away become a white dwarf and planetary nebula. What will happen for a star like that? It will help because of the heat to fuse into many other elements within the shells, and but at the core it will go up to iron because iron is the last element where the fusion is feasible within the star. And then again what will happen is that because of the heat it's going to push it outward, and there will be an explosion of these outer shells, and we call it a supernova, which is so that happens for stars where the mass is really big. And so the supernova is like planetary nebula, but it's very frightening one because it's a massive explosion of the star, and that will brightens up the whole galaxy, and the energy comes out of the star is greater than what we get from sun for the whole life. So after this supernova event, so we have got this white dwarf left. That's the core of the star. And depending on the size of the core, so if the size of the core is 3 times of mass of the sun, what will happen is that we will get a neutron star. So in the previous instance where the star is like sunlight, we got white dwarf, where the electrons vote back to against the gravity. But here, the electrons will, with the protons, turn into neutrons, and there's a pressure from the neutrons that will stop the gravity pushing towards in. So that will become a neutron star, and that star will become really small but very heavy. But if the star is huge, like if the mass of the core is greater than 3 times of the mass of the sun, that means the gravitational pressure is going to push towards in, and nothing, not the electron pressure or neutron pressure, is not going to stop the gravity pushing towards, and this will turn into a black hole. So what is black hole? So it will push towards inside and it'll come to a point. So it will create a region, and in that region that the escape velocity is greater than the speed of light. So even light can't escape from a black hole. So we got 3 different scenarios. One is that a star turn into a white dwarf, and actually this white dwarf will eventually become a black dwarf because it will lose all these lights. It's a very hot and bright object. And then for another, the star bigger than sun, and if the core of the star is less than the 3 times of mass of sun, that will turn into a neutron star. And if the mass of the core is greater 3 times mass of the sun, that will turn into a black hole. That means it's a region where the escape velocity is greater than the speed of light, and it can suck other stars in. So every galaxy, they say that there's a black hole. So this nice picture basically explains everything we have discussed so far. So there's a gas, dust of gas, and that becomes an average star. Depending on the size of the protostar, it can become a massive star, and the massive star will turn into a red supergiant or red giant depending on the size. If it's a star like a sun, it'll become a red giant, and the red giant at the end become a planetary nebula after the core expel all the outer shells, and red supergiant will end up a supernova. And after supernova, depending on the size of the core, it can either become a neutron star or black hole.